Welcome back. This is Mr. Wakefield with our new worksheet packet now, which starts at section 7.7. Last section of chapter 7, which I decided to put in the new worksheet packet partly because it involves something which is going to seem completely different than what we saw in the rest of chapter 7. We talked about it briefly already, but we actually can have a negative number underneath a square root if you expand your horizons to where you're not just thinking of real numbers anymore, but you're thinking about what we call imaginary numbers. All right. In other words, as we learned in section 7.1, if you are just asked to evaluate a radical, which typically means that they're asking for a real number answer. If you get the square root with a negative number underneath, then yeah, you say that that's not a real number. Okay, there is an answer for it, but it's not a real number. Okay, it's an imaginary answer. And so we'll clarify about how you know when to say this versus to say an imaginary number answer. We'll talk about that here coming up. But back in 7.1, we weren't talking about imaginary numbers yet, and so we just gave this answer not a real number when we had the square root of a negative number. Okay, remember, cube roots can have a negative underneath, all right? And as far as fourth roots and stuff like that, all right, we're not going to be talking about that here. We're just going to be talking about square roots in this current section with the imaginary numbers, okay? So, anyway, when we talk about imaginary numbers come up a lot in different levels of math, especially if you go on into future math classes. All right, and so that's why we learn it here. Basically, it's saying that, and let's take a look at the this first problem down here where it says square root of negative 21. It says express it in terms of I and then simplify. Let's talk about this right now. Okay, notice it says expressed it in terms of I. All right. Now, if this had been a problem from section 7.1, you would say not a real number, right? Because it has a negative underneath the square root. In fact, we said that here as we just talked about. Okay. So when you're on a test, how are you going to know whether or not I want this answer or whether or not you're supposed to express it in terms of I, which is obviously implying that you're supposed to give an answer. Okay. Here's how you know. If it says in the directions to express it in terms of I, then I need an answer, and it's going to have I in it. And I'll show you how to do that right now, how to get I into the answer. But if it says anything else, including just right here where it just says to evaluate in the directions, in that case, you guys, that's when you can just say not a real number. Okay? So again, unless it says express it in terms of I, you can take a problem like this where you got a square root and a negative number underneath, and you can just say that it's not a real number, okay? But if it does have these directions right here where you express it in terms of I, you have to actually give an answer with I in it. So how do we do that? How do we give an answer with I in it? Let's take a look up here. I'm going to put square root of negative 21 underneath this thing right here, square root of negative b, and we're going to follow this here, and there's going to be a shortcut to this eventually, don't worry, but I want to show you the long way first. Square root of negative 21, what does that mean? What you do when you have a square root and a negative number underneath, if they want you to express it in terms of I, is you first of all factor a negative 1 out of the negative 21, which makes it negative 1 times 21 like that. Okay, then you split it, okay, like this. Just like we did in section 7.3, okay, you split it like that, okay, when two things are being multiplied together inside your radical, and that's all you have is those two things being multiplied, you're allowed to split it. And then the square root of negative 1, by definition, that's what I is equal to. Remember, you guys, I is not equal to negative 1. I is equal to the square root of negative 1. Which then means that if you square both sides of this equation here, you get I squared equal to negative 1. So it is true that I squared is equal to negative 1, but I by itself is equal to the square root. Okay, so just want to make that clear. So square root of negative 1 would then become your I. I'm just changing the first radical into I. and then the second radical stays the same unless you can simplify it. You then try to simplify it at this point, but 21 doesn't simplify. There's no perfect square number that you could factor out of 21, like 4 or 9 or 16 like we did before. Okay, and so bringing that down here, and you can take the shortcut there. The shortcut with this, going back up for just a moment, is anytime you have a negative number underneath the square root, you can jump from this part right here all the way over to here. And just remember that when you have a negative underneath the square root, it becomes an I on the outside, and then the inside changes to positive. I on the outside, inside becomes positive. That's only if you have a negative inside of a square root, not another root. Okay, I'm just talking about square roots here. Negative inside of a square root, if they want you to express it in terms of I, you put the I on the outside, and then the inside becomes positive. Okay, so that's exactly why we get this answer down here, I square root of 21. All right. And again, the directions say after you express it in terms of I, you simplify. But as we just mentioned, we can't simplify 21. How about here? Square root of negative 28. If we want to express it in terms of I, what do we do again? We change the negative 28 to a positive 28, and then we put an I on the outside. See the similarities there between these two problems? Okay, the negative became I on the outside and positive on the inside. Negative 28 became I on the outside, positive on the inside. Same thing. All right. The difference with this problem, though, is that we can actually simplify it now, because 28 is what? 28 is 4 and 7, isn't it? So just like we did in 7.3, we can factor out the 4, okay? And then the 4, just like we did in 7.3 also, after you factor out the perfect square, all right, you take the radical with the perfect square in it and you evaluate it. And we get what? We get 2. All right, but because we already had the I on the outside, and we've seen this before, if you simplify a radical when there's already a term on the outside of it already, such as I here, okay, you then multiply the old outside part, I, times the new outside part that you just created, which is 2, and that gives me 2I, and then the radical doesn't have anything, there's not another radical to multiply by that. Remember, you're not allowed to multiply something outside of a radical by something inside. So the rad 7 just comes into the answer after you multiply 2 times I. Again, we've done that before back in 7.3, 7.4, 7.5. Okay, those sections. All right. So please try problems 1 and 2 right now. When you're ready to look at those answers, go ahead and hit your play button. All right. Number 1, again, negative 16 underneath the square root, so we make the negative positive on the inside and the I goes on the outside, just like the previous 2 problems. Okay, and then we then simplify the radical that we get if we can. And anytime they ask you to simplify a radical where you have just a perfect square number in there, all right, such as 16, that means to just simply evaluate the radical. All right, so it becomes 4. And I times 4 is equal to 4I. There's your final answer right there. Remember, when you have a negative in front of a radical as we move on to number 2, that means negative 1 times, okay, if it's at the beginning of the problem anyway. Okay, when you have a negative at the beginning of the problem followed by a radical, that means negative 1 times. All right, so changing the negative 27 into I, rad 27, I then have negative 1 times I in the front now, and of course that's equal to negative I. And so that's why you see what you see here. Okay, but then we need to simplify the radical if possible, and it is possible here. Okay, the 27, we can factor a perfect square of 9 out of that, can't we? Okay, and so doing that, we get what we see here. We then, after we factor out that perfect square, like always, we take the perfect square radical and we evaluate that. We get the 3. The other radical stays the same. Okay, just like we did in 7.3 many times there. And then we multiply the old outside part, just like we did in problem B over here. Multiply the old outside part by the new outside part. And that gives you negative 3I, and then the rad 3 just goes on to the end of that answer. Okay. because again, there's not another radical to multiply by the rad 3, so it just goes on to the end there. Okay. All right, so that is expressing a radical in terms of I when you have a negative number underneath the square root. All right. Another thing we need to talk about, branching out even further now from just imaginary numbers, is what happens if you combine imaginary numbers and real numbers together into one single group of numbers. Well, that's called the complex numbers. It's when you take all real numbers and all imaginary numbers and put them all together. The only way to do that, though, in such a way that in such a way that every number is written in the same kind of way, is to have this format called A plus BI. Okay, A plus BI is what we call a complex number. Any complex number, meaning any real or imaginary number, because complex numbers comprise of both of those things. Any real or imaginary number can be written in this form. It doesn't mean it's always going to look exactly like this, but it can be written in that form. For example, since the A and the B are real numbers here, and the I goes after the B here, what that means is that if I make the B equal to 0 right here, then there would definitely be a real number, because 0 times I is 0. And A plus 0 would be just A, which is a real number. Okay? And so any real number in the world, such as, I'm just going to make one up here, 11. Okay? 11 can be written as 11 plus 0I, because that says the same thing as 11 plus 0, which is 11. I'm not saying you would normally write 11 in that way. I'm just saying that any real number could be written in this format here, because you could just put 0I after that. And so my point is that any real or imaginary number can be written in this format here. Imaginary numbers basically are when you have A plus BI, where the B is not 0. Because if the B is not 0, you guys, such as, for example, say I had 3 plus 2I. If the B is not 0 right there, the number being multiplied by I, then that means that the I won't disappear. And when you, even after you try to simplify it, all right, it still doesn't disappear. Not that there's anything to simplify here, but the point is that even after you try to simplify a complex number, if the I is still there, and when I simplified up here, the I went away. When I multiplied 0 times I, it went away, didn't it? Okay, and this was just equal to 11. But even after you try to simplify, if the I is still there, that's what an imaginary number is. It's when the I is there after you simplify, okay? Whereas if you simplify and the I goes away, that makes it real. But in both cases, though, it could be written in this form, but at least before you simplify it. All right, so there's this one form, A plus BI, that could work for both. And so because of that, it's just something that we need to get used to, all right, at least for the next few sections here. And so what's cool about that is it's very similar to a polynomial, all right? As we look at these next 3 problems here, all right, the way we do these problems are very similar to the problems we did at the beginning of chapter 5. Let me pull that out here for you just to review. Notice we have bracket plus bracket, bracket minus bracket, and bracket times bracket. We saw all that before. Let's review that. When you have bracket plus bracket, you just combine like terms. When you have bracket minus bracket, you change the signs of all the terms in the second bracket. This is from 5.1. You change all the signs in the second bracket, and then it becomes an addition problem in the middle here, and that means you, again, combine like terms, because that's what you do when it's plus in the middle. And then what happens when it's bracket times bracket, you guys? As we learned, and we've done this many times since then, when you have bracket times bracket, you then multiply every term in the first bracket by every term in the second one, and you get all these different terms and all that, okay, all that stuff. So we're going to do that same thing right now, all right? Same stuff. There is one other little thing we need to consider, which will be different than what we did in chapter 5. I'll go over that carefully, but other than that, it's very similar stuff to what we did in chapter 5. So bracket plus bracket, if you've got a polynomial on the inside of each, which we do here, okay, It's not your normal polynomial because you got i's in there, but it still looks like one. It still behaves like one, so you can treat it the same way. In other words, you can use the same method that I just showed you, which is what? Which is when you have a bracket plus a bracket, you just simply combine like terms. And so 7 plus 3 is 10. Negative 4i plus 8i is positive 4i. Got to have a plus or minus in between your terms when you combine like terms. All right, so put the plus there. When you have bracket minus bracket, as we just mentioned a moment ago, that means what? That means we change the signs of each term in the second bracket, not the first one, but just the second one. The first one stays the same. And then this becomes plus now in the middle, which then reminds us that since it's now bracket plus bracket, now you can combine like terms, but you got to change those signs first. 6 plus 4 is 10, and then the I terms, negative 3i minus 9i, becomes negative 12i. And there you go. All right, so again, the same thing as chapter 5. Bracket times bracket. Okay, when you have bracket times bracket with polynomials inside of each, what do? You take the first term here, you multiply it by each term in the other bracket. You then go to the next term in the first bracket, you do the same thing until you've done it for each term in the first bracket. So that's a total of what? That's a total of 4 multiplications. All right, again, just like I did here. All right, total of 4 multiplications. Same thing here. So what do we get? Negative 12 plus 30i. Okay, plus 6i in the middle there. And finally, these two terms together is negative 15i squared. Now, there's one thing that we need to do differently that we didn't do in chapter 5, and that's the fact that whenever you get an I squared, you guys, in one of your answers, I need you to simplify it. Okay, if it was negative 15x squared, then you can't simplify that. Negative 15x squared is it just stays that way. All right, but because I squared, you guys, is equal to negative 1, we just learned that a few minutes ago. What you need to do in order to simplify this is I need you to take the coefficient, which is negative 15, and I need you to multiply that by negative 1 because it says to multiply by I squared. So we need to multiply by negative 1. What is negative 15 times negative 1? That would be positive 15, wouldn't it? Okay, so whenever you get an I squared, I need you to take the coefficient and multiply, and what you basically do is you replace the I squared with negative 1. The I squared goes away. You replace it with negative 1, and then you multiply the coefficient by negative 1. And so that's why we get plus 15. And if it is positive, you got to put the plus there, because each one of these 4 answers have got to have pluses and minuses in between them when you multiply bracket times bracket, as we've seen before. Okay, now if this had been plus 15i squared, you guys, which you'll see coming up here and some other problems, then it would become minus 15. Okay, so anytime you multiply by negative 1, it just changes the sign of whatever you multiplied by. So negative 15 becomes plus 15. That's what negative 1 always does. And so if it was plus 15i squared, it would then become minus 15. And then the I squared disappears because you changed it to negative 1 and then multiplied by negative 1, which then led it to change its sign, in this case from minus to plus. Okay, so no more I squared. You transformed it into negative 1 and then you multiplied by negative 1 to get the plus 15. Okay, as always, you guys, after you multiply out brackets, what do we normally do? We combine like terms, and then that's going to help us get it into this form that the directions ask us to do. So put the I term second and the regular term without the I in it first. So that means that I'm going to do negative 12 plus 15 is 3. That's the one that doesn't have the I in it. And then combining the I terms, don't I get plus 36i? And now it looks like it's supposed to look. In fact, all 3 of these answers here look like they're supposed to look right there. They're in the A plus BI form. Yes, that could be a minus in the middle, as you see here in the second problem. All right, this could either be plus or minus, but you got to have just a normal real number here, a normal real number here being multiplied by I. Okay, all right. Now, problem F. it says express these radicals in terms of I, then multiply. Do not multiply them first. Okay, I know some of you might be thinking, hey, wait a second. All right, can't I multiply? In fact, I'll give you a better example here of just to make sure that you're not doing this wrong. Here, we learn that when you have a radical times a radical, if they're both square roots, you can multiply the insides, right? Well, you can do that only if what? Only if the inside parts are both what? If they are both, let me show you the example here. Only if they're both real. See how it says that these things have got to be real here. All right. So both of these radicals are not real. Okay. When you have a square root of a negative number, that is going to be an imaginary number. All right. So what you need to do when you have the square root of a negative times the square root of a negative is I need you to write it in terms of I first. Then the radicals will no longer be imaginary, and then you can multiply. Let me show you what I mean here. So just like we did in the first few problems up here on the top, okay, we take both of these radicals and we write it in terms of I, as the directions say. So negative 3 would become I, and then positive 3 on the inside, right? Just like we did up here. And then square root of negative 18 would be I, and then the negative 18 becomes positive 18. Just doing the same thing as we did up above here, but we're doing it twice. Okay, now at this point, what you do is you just multiply these radical terms together the same way we did in earlier in chapter 7, where if you've got a radical term times a radical term, what do? You multiply the outside times the outside. Gives me I squared. Outside times outside stays outside. Inside times inside stays inside. 3 times 18 is 54, so 54 stays inside. And then, what did we say about I squared, you guys? We said that that was negative 1, wasn't it? Okay, so we have negative 1 times square root of 54. There was no number in front of the I squared like we had with negative 15 over here, so it's just negative 1. Okay, there's nothing being multiplied by there on the front of it. How about the square root of 54 though? If they ask you to simplify your answer like they did up here in the first few problems, what would you do here? You would pull out the 9. You turn the 54 into 9 and 6 in two separate radicals, just like we did in 7.3. Okay, and then you evaluate the radical with the perfect square in it, like always. And as you know, if you already have an outside part before you simplify the radical, you multiply the old outside part by the new outside part. So the final answer is going to be negative 3 radical 6. Now, what if I had done the wrong thing and multiplied these two radicals together first? Okay, and then put it in terms of I after that. Well, what happens is that you wouldn't even need to do the I part if you did that, but it's going to come out wrong though, and that's the problem. If I multiply these together first, I get the square root of 54. But we know that it's supposed to be negative 1 times the square root of 54, not the same thing. Okay, so the lesson here is that anytime you have the square root of a negative number, you guys, immediately change it so that the I is on the outside of that radical with a positive number underneath. Okay, just do it immediately, and then you won't have to worry about messing up any potential rules or whatnot, okay, such as the one where you multiply the inside times the inside. Okay, theoretically, you're only supposed to do that when they're both positive, because they need to be real numbers. But if you get rid of the negative on the inside and turn it into an I on the outside, if you do that first, then you won't have to worry about potentially making a mistake there, using the rule incorrectly or something like that. All right, because now when you multiply them together, they're both positive, and we know that we can multiply those. All right, there's no violation of the rule that I showed you from the previous sections about multiplying inside times inside when they're both positive. So please try number 3 right now, and then hit play when you're done with that. Okay, number 3, again, what do we need to do when we see the square root of a negative number automatically is we need to change it so that there's an I on the outside and a positive number on the inside. So I did that with both of these. That then allows me to what? That allows me to then multiply these radical terms together. You're now allowed to do inside times inside because the insides are positive. All right, and so square root of a positive number, there's no problem multiplying the inside in that case. So we do that. All right, we get I squared. I times I, outside times outside stays outside. Inside times inside, 9 times 5 goes inside. The I squared is -1. Okay, and then what? And then we then simplify the radical. All right. Excuse me, I lost my lead there on the pen. There we go. -1 on the outside. Simplify the radical, and then the -1 gets multiplied by the 3 to get your final answer right there. -3 radical 5. Okay? So that is adding, subtracting, and multiplying. There's one more thing we got to do in regards to complex numbers, and that is how do you divide complex numbers? Now, you're not going to divide it in the normal way, as you're going to see here coming up. Let me use a clean sheet of paper here. You're going to do it a little bit differently, which is going to be similar to something we did a couple sections back. Let me review that with you. Okay, section 7.5. Let me pull that out. Just give me a moment here. There it is. I just need to go to the page here. Okay, 7.5. Remember those problems where you had the two terms on the bottom here? All right, you had the two terms on the bottom and you multiplied by the same thing, but you changed the middle, right? If it was minus in the middle, you changed it to plus, and then you multiply by the same thing otherwise. Okay. If it was plus in the middle, then you multiply by the same thing, but now it's minus in the middle. All right. We're going to do that same exact thing here. Okay. The reason why is because similar to the fact that we wanted to get rid of the radical on the bottom in section 7.5, we now want to get rid of the I on the bottom. Okay. I'll tell you why here coming up. All right. Mainly what it is it's you don't want the I on the bottom, but you want the I being multiplied by this fraction right here. It's not always going to be a fraction, but if it is, you want it being multiplied by I. You don't want the I down here. Okay, you don't want it down here either. But we can make the answer look like this if you multiply by the appropriate thing here. So following that same theme, you guys, if you have 2 plus I, wouldn't I multiply by 2 minus I? Okay, remember, just like in 7.5, you multiply by the same thing in the denominator, except you change the middle. So if it's plus in the middle, you change it to minus. All right, but whenever you multiply the bottom by something, you got to multiply the top by the same thing. Again, just like we did in 7.5, we did that same thing too. All right. Since there's 2 terms on the bottom here, I'm going to put that in brackets just to remind us that when you multiply by a numerator or denominator that has more than one term, you got to treat it like there's brackets there. All right. Treat it the same way. And so what is the bottom going to be equal to here? It's going to be equal to 4. I just multiply this out the same way that I did those problems on the front side of the worksheet here. Problem E. Okay, that we just saw. Just multiply it out the same way because both brackets have 2 terms in it. We're going to do that the same way here. I get 4 minus 2i plus 2i minus I squared. Okay, now, what is all that equal to? Well, if you do this correctly, these 2 middle terms should always cancel out. All right, and it should just leave you with the first one here and the last one. 4 minus I squared. But remember what we said. Whenever you get I squared, convert that immediately to -1. But isn't there already an invisible -1 in front of that? Because it says negative or minus I squared. So you have -1, which is invisible here, times I squared, which is -1. So negative I squared becomes, this whole thing becomes what? It becomes +1. Okay, the I squared is -1. The negative in front of it is -1. -1 times -1 is +1. So we end up with what here? We end up with 4, and then this transformed into +1. Combining like terms, 4 plus 1 is going to be 5, as you know. Okay? All right, now we need to multiply the top, but that's what we want to do, though. We want to get the answer here simplified on the bottom, multiply it out, combine like terms. Some terms are going to cancel. Simplify your I squared term like we talked about, and it should just give you just a single real number on the bottom every single time when you divide complex numbers, every single time. Now let's distribute out the top here, okay? And that gives me what here? It gives me 10i minus 5i squared. And there we go again. We got another I squared. So what is minus 5i squared going to become, you guys? It is negative 5 times negative 1. The I squared becomes negative 1. So negative 5 times negative 1 is going to be plus 5, isn't it? So we have what now? We have 10i plus 5 over 5. 10i plus 5 over 5. How do we get it to look like this? Okay. And I had to multiply out those brackets on top because there's no brackets in the answer here, so I had to get rid of those. I knew I had to do that. And you definitely want just a single real number on the bottom, no I down there. Now that I've got all that, let me just rewrite what I got here. I got 10i plus 5 over 5. Now what you do at this point is you do the same thing we did back when we were doing the mx plus b problems. You got two terms on the top divided by a single term on the bottom. Okay, you got what here? What you do is you divide each one individually. 10i divided by 5, positive divided by positive is going to be positive. All right, and then positive divided by positive again is going to be positive, so we put a plus in front of that, just like we always do when we have a polynomial divided by a single term. All right. What is all this stuff? What are these two fractions equal to? Remember, you got to put each fraction in lowest terms after you split it like that. We've been doing that many times throughout the semester. It's no different here. What do we get? We get 2i over 1. You're not always going to have a fraction here. I know it says that these need to be fractions, but they don't need to be if the denominator is 1. This is 2i over 1 when you reduce this thing to lower terms here. And so you can just say 2i when that happens. Okay, if the denominator is anything other than 1, then you got to write the denominator, of course. All right, 5 over 5, that's going to be 1 over 1, which is 1. And so we end up with 2i plus 1. All right, they want you to put the term that does not have the I in it first and the term that has the I second. So officially our answer should be 1 plus 2i. You just reverse it around. And we know how to reverse around two terms that are being added or subtracted. Just make sure that they have the same sign when you reverse them around, the same sign in front of each term, and that you still have a plus or minus in between. Okay, because it's still got to be two terms. I did that, and so now I did it here. It's just that, you don't need fractions if there's a denominator of 1 for both of these numbers, 1 and 2. All right, and the denominators were equal to 1. But we did it, though. We put the term that did not have the I in it first, and then the term that had the I in it second. And so it officially does, it officially is in this form right here. It's just that you have some invisible denominators right here that are equal to 1. Okay, but we did what they asked us to do, though. All right, you don't need to write those denominators when they're equal to 1. Let's try that again. What do we multiply by when you have a minus in the middle on the bottom there? You multiply by 3 plus 2i. 3 plus 2i. In other words, you change the middle, but otherwise you multiply by the same thing as you already had on the bottom. Okay, so 3 minus I, that means you multiply by 3 plus 2i. Okay, multiply the top by the same thing as well. I'll get to that in a minute. Let's do the bottom here first. Put these in brackets here because they've got more than one term and you're multiplying them by something. Okay, but what does the bottom become when you do that? It becomes 9 plus 6i minus 6i minus 4i squared. Okay. Again, just like in the last problem, change the second that you get I squared, transform it. This should be negative 4 times negative 1. Negative 4 times negative 1 is plus 4, isn't it? plus 4. Also, when we combine like terms, the 6i terms cancel, and so all we have left is 9 plus 4. Okay, so get rid of that I squared so that you can then combine the 9 with the 4. Get rid of that first. So we end up with what on the bottom here? We end up with 13, don't we? 9 plus 4 is 13. Okay, now we need to, and again, that's what we wanted to do. We wanted to make the denominator into a single real number, no i's down there. Okay, just a single real constant number. Multiplying out the top here, what do we get? 15. Again, you have two terms in each bracket, so we're going to have 4 multiplications we got to do here. 5 times 3 is 15. 5 times 2i is plus 10i. Negative I times 3 is negative 3i. And finally, negative I times 2i squared is negative 2i squared. After you multiply out the top, if you get an I squared, immediately change that. All right, right away, just like before. And isn't that going to be plus 2 right there? Okay, negative 2 times negative 1, plus 2. Then you combine your like terms after you multiply out the top. I didn't have to do that over here on the previous problem because there weren't any like terms after I got rid of the I squared. But if there is, do that. We get what? We get 17 plus 7i. Put the 17 first because eventually we're going to want the I to be second anyway in the answer. And then, just like we did in the last problem, okay, and I know I didn't put the I first here, you guys, over here. Maybe I should have, but I eventually turned it around. So you could turn it around now or later. That's okay. You didn't have to put the 17 first right now. You could go either one, but I figured why not just put the 17 first since we got to turn it around eventually anyway. Over here, there were no like terms to combine, so that's probably why I just put the 10i here first. All right. Because there was no like term to combine anyway. So I just left it that way and then changed it later. But the important thing is that eventually you need to put the term that doesn't have the I in it first. Okay. But it is easier though just to put the one that doesn't have it, the I first. So if you can, go ahead and do that. So what I do the same thing I did in the last problem here, which is I've got the two terms on top, I divide both of them by the single term on the bottom. Okay, that gives me what here? It gives me positive divided by positive is positive. So you don't need to put a plus like you normally would in the front of this because it's the first term or the first fraction. And then the second one's also positive divided by positive, so that's going to be positive, and that's why I put the plus in front of that. Now, notice that the answer wants you to put the I behind the fraction. Is that okay for me to just move that I behind the fraction? Absolutely it is. And let me remind you of why. Back when we were doing mx plus b problems before, all right, and we had, say, 3x. You don't have to write this down, but if we had like y equal to 3x over 5 plus 2 or something like that, remember we were allowed to put the x behind the 3/5 there because the x was being multiplied by the 3. As long as it's being multiplied by the rest of the numerator there, you can move the x behind the fraction. Same exact thing just happened here. The I is being multiplied by the 7, so you're allowed to take that I and to put it behind, like they asked you to, all right, put it behind the 7. And now it looks exactly like they told us to make it look, okay, the fraction plus, and this could be a minus also, not in this case, but it could be, fraction plus or minus here, and then a fraction times I. That's what they wanted, and that's what we got. So we're good. Okay. You can go ahead and put your fractions in lowest terms after that, but these fractions already are in lowest terms, so that's why I circled it. Okay. One additional note here that I have for you before you try these last two problems. Notice that this only has one term right here. Okay, well that's similar to, and you don't have to write this down, but that's similar to 0 plus 5i, isn't it? When you have 5i, it's the same thing as 0 plus 5i, so that would be the a part of the a plus bi format that you have for complex numbers. The a would be the 0. What's the what would you multiply by if you had 0 plus 5i? Wouldn't you multiply by 0 minus 5i? Aren't you just supposed to change the middle? But what is 0 minus 5i? That's the same thing as negative 5i, isn't it? Okay? That's the same thing as negative 5i. So when you have just a single term like that, what you do is you just change the sign of that term, and then the 0 part you don't need to write. Because when you add 0 to something, it doesn't need to be written, correct? Okay, so we've seen that a number of times before. With the 0, you don't have to write it. So that's what you multiply by. I'll let you finish this up. Don't forget you got to put a bracket around that because that's got 2 terms. I put a bracket around this even though it's got only 1 term because it's negative. And we put a bracket around a negative that we're multiplying by something else. It's just something that we do. Okay. So I'll let you try number 4 as well. So go ahead and try 4 and 5. Just continue on with what I wrote here in number 5. Again, you don't need to write down this stuff here. I was just showing you how I came up with negative 5i as the correct thing to multiply by. So please go ahead and try 4 and 5, and then we'll take a look at those answers when you hit the play button. Okay, number 4 right here. What do we multiply by, you guys? If we have 4 plus 2i, wouldn't we multiply by the same thing, but now the middle is minus? All right, so if that's why I multiply by 4 minus 2i. What does the bottom end up becoming? Let's figure that out first. All right, the bottom is going to be, and notice I kind of wrote it a little bit differently here. I didn't write down the 2 middle terms here because I knew that they were going to cancel out anyway. I'm sorry, that came off the screen there. There it is. Notice I wrote down just the first term, the first multiplication, 4 times 4, and the last one here. All right, the reason why I did that was because I knew that the negative 8i and the 8i were going to cancel already, and so I just didn't bother writing those. Okay, so you could skip that as well and just write these 2 terms, all right, knowing, and again, this is just on the bottom that they cancel for sure. On the top, they might cancel, they might not, okay, so don't assume that they're going to cancel on the top for sure, but on the bottom they will if you do this correct. So you can just do the first term and the last term here, multiplication, because you know the other 2 terms are automatically going to cancel. I get 16 minus 4i squared. But we know that minus 4i squared is the same thing as plus 4. And so what does that do to our final denominator here, at least for the next step? It makes the final denominator equal to 20, okay, that you see right here. All right, so what about the numerator then? If I multiply these 2 things together right here, I get these 4 answers here. But we know that plus 6i squared is the same thing as positive 6 times negative 1. I squared becomes negative 1 as usual. So positive 6 times negative 1 is going to be negative 6. All right. Combining like terms, we get 24 minus 6 is 18. Sorry, let me zoom out there. That fell off the screen there again. There we, a little bit more here. There we go. And so the 24 and minus 6 become 18. And then these 2 terms combine together to be minus 24i. The bottom is 20, as we already established. We then what? We then, now that I've combined like terms there, and in particular I have the term without the I first. All right. Again, you want to do that normally. That way you don't have to worry about turning it around at the end. All right. And we get what here if we actually split this apart, which is what we do next after we got the 2 terms in the correct order up here. We get this right here. All right. Positive divided by positive is positive. So nothing in front of that since it's the first fraction. The second one here is negative divided by positive, so I got to put the minus in front to indicate that it's negative. All right. Again, you can pull the I out of the, normally this would be 24i inside of the numerator, but you can pull the I out of the numerator like we said in the last problem. And so this essentially is the answer right here, but we could also, and I'd like you to do this just because we normally do it, go ahead and put your fractions in lowest terms after you pull the I out of there and you have the correct format here. That would be what? That would be 9/10. Okay, let me get that. There we go. We have 9/10. 18/20 becomes that. And then 24/20, that reduces down to 6/5. Okay, so that's your final answer right there. Okay. So yeah, go ahead and split that apart like we said, pull the I out. And then if the fractions can be simplified after that, please do so. All right. So that is number 4. Number 5. Multiply by negative 5i. The bottom, you just have a term times a term. All right, we're not distributing because we don't have like more than one term here. We don't have more than one term here. You're just doing a single term times a single term. So that would be negative 25i squared, wouldn't it? But we know that whenever we get I squared, we want to change that to negative 1. And so negative 25 times negative 1 is just 25. You don't need to put a plus in front of that because that's the only term that you have. You don't have anything in front of the 25. All right, so it just becomes 25. On the top there, when you got 2 terms in a numerator, bracket that, as you know, because it's got more than one term. But when you do multiply by just a single term, then you just distribute. Okay, anytime you got a bracket with more than one term being multiplied by just a single term, you distribute the single term. All right, and we get this right here. Change the negative I squared, or pardon me, change the I squared to negative 1. That makes this plus 20. All right. Go ahead and switch it around now. Like I said, it's easier than doing it later. So I'm going to put the 20 in front of the net minus 15i right here. Split it apart, like right there. Okay, so 20 25ths minus 15 25ths. Put the I in behind it. All right, just like we've been talking about. And then the only thing left to do is that since both of these fractions can be put into lower terms, do that. Okay. But otherwise we're done because we have it in the correct form. We have a fraction and then another fraction times I after that with either a plus or a minus, in this case a minus, in between. Okay, so that is section 7.7, dealing with imaginary numbers. And if you have any questions about this, as usual, contact me, and have a good day.